This is AQA A-Level Chemistry. We're on the Group 2 topic, the alkaline earth metals, and this is video 2. So as always, I'm going to recommend that you pause as you go, try the activities, and then review your answers. So in the first instance, we've got some questions here about magnesium reacting with water. Now actually a huge amount of information has been given. Magnesium reacts with water to make magnesium hydroxide. You have got to remember that hydroxide has a charge of -1, magnesium has a charge of +2, so the formula of magnesium hydroxide will be MgOH2. You also actually need to remember something that hasn't been provided in the question, and that is that we also make hydrogen in these circumstances. Group 1 with water will make the metal hydroxide with hydrogen, and actually the same thing happens for the metals that are reactive enough to react in group 2. So once we've done that, we need to balance it. So we need a 2H2O and a 2H2. And finally, we should be at the point that we're putting state symbols in. So magnesium a solid, H2O liquid. We've got the magnesium hydroxide is going to be aqueous, the bit that we make, and hydrogen is a gas. So it is much faster if we do this with steam rather than cold water. Why would that be the case? Well, this takes us to the kinetic topic, to rates of reaction. And what I'm hoping that you recognised is that increase in temperature does cause an increase in rate of reaction. Approximately 10 degrees Celsius increase will lead to a doubling of the rate of reaction. Now let's take a look at what happens if we do that reaction, magnesium with steam. What observations would you make? Or indeed, if you've seen this practical or watched on a live YouTube video, what did you see? Well, with magnesium, you get a very intense white flame. And you also get the magnesium oxide left behind, which is a white ash. And the hydrogen that's produced, we've ignited, you can see on the picture, and that burns with an orange flame. Now there is a significant difference here where the magnesium reacts with steam rather than cold water. So it still says here magnesium reacts with water, but we're talking about water in the gas phase. And we don't make magnesium hydroxide, we make magnesium oxide. So Mg, solid, plus H2O, gaseous, got to make sure that that's right in the context of this question, goes on to make MgO solid and H2 gaseous. So what would it look like for calcium, strontium and barium with cold water? Well, let's do all of these together. We've got our calcium, strontium and barium solid, and we're adding to that H2O, and it's cold water, so it's in the liquid phase. Now, because calcium, strontium and barium are all +2 charges, because they're in group 2, that means their formulae will all be very similar of the hydroxides. Calcium hydroxide, CaOH2. Strontium, SrOH2. Barium, BaOH2. And they're all aqueous. And in every single case, we make hydrogen, diatomic, H2 gas, and we have completed. So if you replace Ca, Sr and Ba with M, and you replace them here with M, what you find is that we've then got a general equation, just like we do with group 1. Okay, now let's take a look at the solubility of group 2 sulfates and hydroxides. These are two trends you have to remember, and we're going to talk about some key ideas that will help you to remember it and that you might well be asked about. So have a read of this, and when you're ready, unpause the video and see how you've done with the question. So the key thing to look for here is that barium ions are incredibly toxic, and yet we can drink barium sulfate. Now that tells us that barium sulfate is totally insoluble. It's lower down the group, so that would lead us to believe that solubility decreases as you descend the group. A really important trend for you to remember. It's not the only place that we rely on the insolubility of barium sulfate. Have a go at these questions. So the test for sulfate ions, one of many chemical tests that you need to know. We add barium chloride, and If there is a sulfate ion present, we end up with a white precipitate. So what's the ionic equation for that? Well, I'm going to build the ionic equation from first principles. So let's start with the equation itself. Sodium sulfate, Na2SO4, barium chloride, BaCl2, my barium sulfate, BaSO4, and my sodium chloride, NaCl. The barium sulfate is the white precipitate. It's solid. We have to remember that. And that's vital for when we move on to do our ionic equation. I've balanced it there, so we've got 2 NaCl. And now let's break down the aqueous ionic substances. So I've got 2Na plus and SO4 2 minus. I have Ba2 plus and 2Cl minus. I haven't broken down my barium sulfate because it's solid. It's insoluble, so it doesn't break down into its ions. And I've got my 2Na plus and my 2Cl minus. Now we can get rid of the spectators. My Na pluses appear on both sides. My Cl minuses appear on both sides. So I can now write my ionic equation after getting rid of the spectators. Ba plus 2, aqueous, plus SO4 2 minus, aqueous, goes to BaSO4, solid. So that's sulfate ions. Now let's have a look at hydroxide ions. So work through these questions and then review. So milk of magnesia used to treat acid indigestion. Barium hydroxide would be far too dangerous as it would produce a very strong alkali. Now that tells us that the solubility of hydroxides increases as you descend the group. It's the opposite trend to what we see with sulfates. So the magnesium hydroxide barely dissolves. When you get an alkali that is very soluble, that will mean, and this answers the final question, it would be a very strong alkali, and that would make it very, very corrosive. So it wouldn't be untrue to say that barium hydroxide would neutralize stomach acid, but it would cause significant damage to your body as you try to drink it. Okay, barium hydroxide fully ionizes in solution. Write an equation to show this. So we start with our barium hydroxide, BaOH2, and we break it down into its ions. We have Ba plus 2 and 2OH minus, and I've got the state symbols going all the way through there. That brings us to the end of the video part 2. It also brings us to the end of the group 2 topic. Thank you for listening. Goodbye.